Hey everybody, thank you for coming. I hope you've been enjoying ReactiveConf so far. My name is Luis Roman, and I'm going to be talking about type higher order components with Flow. I'm a senior front-end developer at STRB, which is a company based here in Prague. And before jumping into the presentation itself, I want to talk to you a little bit about my last weekend. So this is me watching ReactiveConf. ReactConf, and I'm joining Dan Abramov talking about these cool things called HOCs, and then suddenly I'm starting to think like, hooks, HOCs, and then I suddenly realized that, oh shit, I have a presentation about higher order components, and this guy is coming with this new cool stuff that might make higher order components obsolete. So I was, propagating some dark energy, wishing he would get a blue screen of death, but then I realized he was using Mac. So I calmed down, and some sense came to me, and I realized that, okay, they're still in alpha, higher order components are still valid, and we'll still need to be able to work with higher order components on current projects. Hooks are bleeding edge, so before they stabilize, higher order components will still be very, very valuable for us, and we'll still need to be working with them. So now to the talk. Now, the first part, I'm just going to explain a little bit about higher order components and a little bit about Flow, so everybody's on the same page. Probably you know some of this stuff already, but then we'll jump in the third part into how we can type them. So let's check the base signature of a higher order component. It's just a function that takes a component as input and returns a new component. The component it returns is an enhanced version, which might have like extra properties, or during this process of enhancing this function, we might perform some side effects. And if we go to the React inspector, we'll see that the JSX that corresponds with this enhancing will look like this. The outer enhanced component is going to be outside, and inside is going to be our nested component. So now let's take a look at a practical example. Let's assume we have a reviews class-based component that look like this. I hope it's big enough. Yeah. What it's doing is on component did mount is gonna fetch some data from the server, and then when this data comes back, we're gonna map it to our state. It's pretty straightforward. Now, if the data is not already there, we'll show a loader, and if all goes right, then we will do what we actually wanted to show on the first place, which is the JSX, the HTML that corresponds to the reviews. So the list, the styles, everything that goes there that matters. So all is cool, but let's say we have more components. So now we have a films component. This films component is doing the same thing as the other component was doing. So it's just the thing that changes is just the route and the mapping, and then of course, what we return on the actual render. So the HTML, the styles might be different, the data is different, but the rest is just the same. So we're kind of having to copy paste the same logic every time we go to different components, and the actual render method gets a little bit obscure because all these extra logic just to perform this fetching. So this is a problem that higher order components could solve. So let's take a look how it will look. Same version, but stateless. Here we have just a function-based component, and it's pretty clear straight away what is the HTML of this component. It's pretty straightforward. And then on the bottom, we configure our higher order component, which is this function here that we just pass the URL and the data mapper that we need. And then on the bottom, we just enhance this films component and we get the same functionality we had before, but now this enhancer is something we could reuse in our reviews component or in any component, and it's pretty clear. The HTML and the logic is going to be down the bottom. Now let's take a look at how this with data fetcher looks. So the first part is just we have the configuration part. So we pass the URL and the mapper function, and what we're going to return is the actual higher order component. So the first function is just configuration. Second is going to be higher order component. It takes the base component. In previous case, it was the films, and now we return a class-based component. And this class is going to look very similar to what we had in the beginning. And component.mount is going to fetch some data, and it's going to use the URL that we pass and the mapper, and it's going to then change the loaded state to true whenever we get this data. Render method will look similar as the films, and so when the state is loaded, when the state is not loaded, we will show loader, and otherwise we will combine the props, the state, and we will pass this to our base component. So it's pretty much we just extracted what we had on the first component, and we just put it here in this function that wraps whatever we call with it. Now I like to think as for higher order components as something like a checklist. So we can take whatever we have on our list of higher order components and just check what we can use to enhance the components we have. So let's say we have a loader, and then we want to add with data fetcher to this component, and let's say some extra random functionality, and it becomes very trivial to just add or remove data functionality to our components. And of course, this also makes possible that we can share easily all this functionality. So composability is what higher order components provide. Now let's take a look now at a little bit of flow. We're just going to cover what we're going to need to understand how we can type higher order components. So let's take a look at the basic typing. We're going to have this square function, which just take x and multiply it by itself. That's it. So what we want to do is we're gonna type the input, which is the first x. To do it, we just put this colon and then the type that we want. These types could be strings, arrays, objects, whatever you think as any basic or primitive type in JavaScript, you will put it here. And then for the return type, the only thing we do is after the colon, after the parents of the function, we just put colons and the type. Now it's pretty basic, but it's pretty important that you remember the positioning, because in higher order components it can get a bit messy. Now another important part that we need to understand is generics. Generics is a powerful concept that some type system use to introduce some sort of type variability in the normally hard-coded types. We usually just type in, this is a number, this is a string, this is an array, but generics just provide us with a way to be more dynamic. So let's take a look here. We just have identity function that takes some value, returns same value. Pretty simple. And on the second line, we're just calling identity over 5, and this is supposed to return a number. Now, to use generics, the first part that we're gonna need is to add these angle brackets before the function parents. And this is gonna be like a let variable definition in JavaScript. This is just the name of the type variable that we're gonna use. There's nothing special, it has no value at this point. It's just where we define it. Now, we want to get the value. So to get some type value to this t, we're just gonna put it here on the input, and the value will flow from whatever we pass when we call this function. It's just at call time. When we call this function, the type will flow to the t, and then eventually it will flow to the left. So this T that lives on the left will have our number type in this case. Now that we have it here on the left, we can reuse it in the return type or whatever we want. In this case, it's just for the return type. So just think at it as we're replacing this by actual types, but we didn't have to specify them. Okay, now let's take a look at object spread. It works pretty much as in JavaScript. We have two type objects here, and what we want to do is that we want to take the properties on the first object and extend the second object with it. So what we do is we just put the ... to spread it, and that's it. This vector object will have the three properties, x, y, and z. And in reality, we'll need to add this exact wrapper around it, but I'm not gonna show it on the next example. Just be aware that you will need it. Now, we're finally into the part that we wanna discuss. So let's start by talking about the most basic element that we want here, which is the component. A component, if we just think on functional components, is just a function that takes some properties and returns a React element. Now we're here defining an alias just to make a shorter version of this. So what we do is define this $sign component, and whatever we have this input P, and it will flow here to the P on the right. So this will be our props. The problem is that this will only work with function-based components, and we have class-based components. So Flow already provides us with the utility function that will do this for us. So this will be the same thing as before, but it will also work with classes. Though we'll still be using this $sign component just to make things a little bit smaller. Now, probably you have tried to type higher components before, and one approach could be not using inference at all. So let's say we have a lucky number component, which renders a string that depends on name and random properties to exist. We define them on the top, and we say that the argument equals to these props. Now, all good here, but if we're gonna use a higher order component here, like these props are going to be provided by two HOCs, then we will use with random, which will provide random property, and map state to props from Redux, and this will provide the name. And now we want to enhance it and return. Now, because we're providing these properties from the higher order component and not from the parent, we need to cast the result of enhancing this and say, this is a component that expects no properties at all. So when the parent calls this, Flow won't give an error saying, hey, you're not passing me random or name. Now, there are several problems with this approach. The first one is that there's no type safety here in the enhancers, or compose function is literally not type check at this moment. So we're just bypassing this. And we're also duplicating the properties that the higher order component is going to add. So we have to check with random is going to add this property, connect is going to add this other one, and if we remove one, we need to update our props. But what we want is some sort of cohesion between the types and the higher order components. So we add something, it adds the types immediately. So how we can do that? Let's take a look at the higher order component with random, which will just take base component and return an enhanced version, which will have this random number and the rest of the property. It's pretty simple. And let's say on a different file, we have this lucky number, which is the same one as before. And we're just enhancing with random, and that's it. If you notice, now we're not using map state to props. So name has to be passed by whoever calls this lucky number. So let's start typing. So the first thing that we're gonna focus is on the return type of the higher order component. So by adding this after the parents, we just say, hey, this whenever we call this, we're gonna return a component that takes no properties. And if we inspect what is on the wrapper side on the bottom, we'll see that this is a component that takes no properties. So at least this is now a component, but it will not be very useful because the inner component lucky number won't even have any kind of type. It will be type empty, and basically it will not be type safe. So let's work now on the inner component, the base component. We do the same thing. We say base component is this component with empty properties, and that's it. Now, just remember that this is going to be what is in what's going to be wrapped. So in this case, a lucky number, and Flow will know that the props in this case is an empty object. Now, name and random will have some error because, of course, name and random does not exist in this empty object. So let's keep working on that. But let's focus again on the outer component. Now, whenever somebody calls lucky number from outside, we want them to pass the name. And in order to do it, we specify here on the return type of the HOC. And now whoever calls this needs to pass name, otherwise we'll get an error. If we inspect what is with random now, it's going to say is this component with the expecting name string. Now, let's type the inner component. We're going to say that the base component is going to take properties name and random. So this will match directly with whatever we call. So in this case, it's going to be lucky number, and the props is going to turn into being this name and string and random number. So right now, it is completely type check, but the problem is that everything is tightly coupled between the higher order component and our component that we want to enhance. So this will only work with lucky number, which is terrible, but at least this is what we want to get inferred by Flow. So let's start adding some generics. And just remember, we just put in the angle brackets before the function call, the P, which is gonna be our props. And what we want is get the properties from the parent, so the properties that are passed to this component. So we're gonna replace P in the return type in the outer component. But right now, we have no types because nobody is specifying that this component is gonna need name as a string from outside. So we need to add this casting again, and what we're saying here is that this is a component that takes name string, and whatever we put here on the component is gonna flow directly to the return type. So now Flow can infer whatever we put here on the bottom and is gonna use it here. Now, as you can see, we have now name string, and we also use it on the inner component. So we can replace what we previously have, and that way we just spread the P, which contains the name string, and right now we will have exactly as we did before, but just with type inference. So this component is no longer coupled with this higher order component is no longer coupled with this lucky number, because we're just taking whatever is inferred on the casting from the bottom and then spreading it inside the base component. Now, we could do even a bit better. This is fully typed. There's nothing we can improve on the typing so far, but we can make it more easier to add these higher order components types. So what we could do is create a helper. So let's say here we just have this type HOC, and the only thing we're going to pass is the extra properties that this higher order component is going to be adding. And on the right is just the normal signature that I showed you before. So it's just a function that takes a component and returns the new component. You will notice that we have here the angle brackets with the P, and on the return type we also have replaced the P. So it will work similar as before. The only thing that we have to do now is spread what is passed from the parent from outside into the base component, the one that comes as input, and we add the extra properties that we specify on the left. So now it becomes very trivial to type our components. So let's say we have again the same with random, but there's no types. There's nothing here. So the only thing we need to add now is this helper and specify what is this higher order component adding in general. In this case, it's just one property, random, and this is going to be spreaded in our helper. Now we could use the same thing as we did before, and that's it. It will work exactly as it did, but then we could declare this HOC Helper as a global, and we could reuse it in many places, and it becomes very, very easy to just type at least this type of component. So wrapping up, HOCs are still valid, so extract all generic functionality you can into higher order components. Now you know how you now know the building blocks to type your higher order components, so please do so. And just remember, if we use type inference, we'll bake the types directly into a higher order component. So every time we remove, let's say with random, it will change the types automatically that the component is going to be expecting. There's no need to duplicate the code, and this is a problem that it's currently with TypeScript, that we have to repeat our props again, and in some flow code bases that we have a lot of long list of properties that are coming from higher order component, especially from map state to props. All that could be inferred just by using this. There's no need to retype again. And just remember, HOC is just a pattern. There is also the new hooks, which are in alpha but might be interesting in the future, and there is also render to props. But I think I really like higher order components, so I hope you learn something, and that's it, guys.
Thank you very much. So again,
you have questions? Yeah.
First off, why did you choose Flow over TypeScript?
Okay, I was using TypeScript before, like 2 years ago. It was pretty good, but the support for React was not that good at the moment, so I switched to Flow, and yeah, if you want. I switched to Flow, and it was a pretty interesting experience. Now TypeScript is gotten way, way, way better. It's really good at this point, and this might change in the future, but still, when we're using higher order components, Flow will have the upper hand, because there is no way at this moment that TypeScript can get this type inference that I show you. You have to type exactly every property that you expect. Now, I'm not expert in TypeScript, but it was like this last time I checked, but this might change in the future. So that's like the main reason I choose Flow over TypeScript.
Right, thank you. I think you addressed both of the next two questions in one of your last slides, but if you want to address it furthermore.
Okay, there are different patterns. They're pretty useful, but render to props is good when you want to be like very explicit about what you're going to do. So it's very useful in some cases. I use them a lot. But if I want to like add 5 higher order components, I will probably not be doing that with render to props because it will become a mess in nesting all these JSX. So I really like to keep, at least on my code, even though the React inspector will change, I like to keep flat my enhancing. So if I want to be very explicit and it's only one thing that I want to enhance, I will probably use render to props. Otherwise, I'll just be using hooks. And do you think? I do think that higher order components will become less used, but I'm thinking that there will be some sort of combination between higher order components and hooks. I'm not an expert in hooks, but I do like that in higher order components is sort of like a dependency injection. You will be injecting the properties from outside the component. And with hooks, you're pretty much what you import. You will have like direct dependencies there in the render method. So at least probably I'll be using an outer higher order component that will inject the properties that comes from the hooks. But I still haven't experimented a lot with it. But I still think that higher order components will be used in at least big code bases right now.
All right, thank you. And the last question, we still have a couple minutes. So, are you hoisting non-React statics and following graphs?
Are you hoisting?
In higher order components. And also, you can address the render props part.
Okay, I honestly haven't run into this, so unfortunately I cannot answer this one.
All right. Okay. So, thank you very much again.
Okay, guys.